Hello and welcome all. This is a live demonstration of my AI-powered cloud monitoring system, where I firstly created a VM instance on Azure which you can see is in running state. Next, I collected the data. On the VM, Telegraph's configuration includes two input plugins, CPU and memory, and a file output plugin, as shown in this telegraph.conf file. Every 10 seconds, Telegraph appends a new line of metrics to input_metrics.csv, including timestamp, CPU percentages, total and available memory in bytes. Next is the Python pipeline. In train.py, we loaded the CSV with pandas. Then I filtered out any stray header rows by coercing timestamps to numerics. Here I selected three key memory features, available, total, and used, and convert them to floats, and then dropping any rows with missing values. I then normalize each feature to mean 0 unit variance using standard scalar. This prevents any one feature's scale from dominating our distance-based algorithm. With scaled data in hand, we instantiate an isolation forest model. Here n estimators tell the number of trees used by the pre-trained model. The forest isolates each data point in random trees. Points isolated quickly are deemed anomalies function, which gives continuous value where lower means more anomalous. Also, computing labels using predict function, which returns -1 for anomalies, +1 for normal points. And then the data is write out to the output CSV file, which using a path in VM and will be named as output_metrics.csv. In order to eliminate manual installs on each VM, I containerize everything. Here you can see my Docker file, where I use the base image as Python 3.9 Slim. Here I apt-get install Telegraph and its dependencies. Copy in telegraph.conf, train.py, requirements.txt, and an entrypoint.sh. Also using pip install for Python libraries. Entrypoint script launches Telegraph, loops training every minute, and starts an HTTP server on port 8080 to serve the CSVs. Here you can see the snippet of the entrypoint.sh file, which serves at the port 8080. And here is the requirements.txt file. Next, I install Docker on the VM, and then build and publish image to Docker Hub. Next, I run the container with the docker run command, as you can see over here. This single command installs Telegraph, starts metric collection, runs anomaly detection, and serves the results. No further manual steps required. Here we can see that the model folder contains the two joblib files. And here within the data folder, there are two CSV files. One is the input from Telegraph and the other is output file from the anomaly detection model. As you can see, this is how the file looks like. Finally, let's look at this Grafana server. Using the Infinity CSV plugin, I configure a data source. I use the same URL which uses 8080 port and kept the parser to CSV. This time series graph shows a green line which shows the anomaly scores in CPU. The gradual decline before the spike shows the classic ransomware behavior, slowly consuming resources. On the memory panel, most of the anomaly scored hovers above, indicating normal operation. But each time the yellow line dips below 0, it corresponds to the higher suspicion, which means that the model flagging a potential memory spick or a leak. Hence, we can spot the memory leak patterns or ransomware encryption phases in real time. Here you can see the visualization for other metrics. The blue line shows the available CPU. You can immediately see when the VM deviates from the baseline. For the scaling purpose, in order to have every VM in the fleet automatically join the monitoring system, simply we need to include these steps in the VM provisioning. We just need to use this YAML into the custom data field when creating new VMs in Azure, AWS, or any cloud. We can just apply the same Docker run commands via a custom script extension, Azure, or user data, AWS, so every instance in your scale set automatically boots into monitoring mode. If you manage servers with Ansible, Chef, or Puppet, a simple playbook can install Docker, pull your image, and start the container on every host. Hence, the deployment via Docker could be done on any number of VMs. This completes our journey from raw VM metrics to automated, scalable, AI-driven cloud monitoring. Thank you.